Hello dear viewers, welcome to another Geonodes Daily series tutorial. And in this one, we will look at how we can create this awesome effect that you see here. And this is very interesting because it will allow us to see how we can mix two effects together actually and randomize the effect. We also take a look at how we can use geometry nodes to mix materials, and that's gonna be a lot of fun. I had a lot of fun creating this project, and I want to share with you what I learned doing this. So we will follow these steps that you see in this card in order to recreate the geometry. And if you want to see how the materials were made, check out the link in the description or the one that appeared during the demo. So before we start, as usual, I want to give a big thank you to all of you that are supporting this channel. Thank you to all of you that are purchasing the project files from Gumroad, like this one. Thank you for all of you that are subscribing to this channel, liking the videos, commenting on them. And of course, thank you all of you for watching these videos. This really helps the channel to grow. So the first thing I want to do before we start, it's explaining the idea behind this entire process. So we will take a piece of text, doesn't matter, can be any text. Let's say the letter T, and basically let's make it like this. We will create an effect that gives that squiggly line appearance, and we will create that growing pin effect, and then we will mix those two together. And of course, in order to get the result in the demo, we will have to create a mask to separate this text into two pieces. So that's kind of the basic idea from this one. So let's get started with creating the squiggly line effect. And being a text, of course, we will need a string to curves. Let's plug this one here, and I'm gonna disconnect this input. We will use it maybe later. Let's delete it to keep things simple. And in order to also keep things simple, so I'm just gonna use one letter. This way we don't waste too much resources on this. So we have this line output, and if we want to deform it, we will need a little bit more resolution. So let's do that. Let's add a curve, the sample curve node. I'm gonna plug it here, switch it to length because I want to have a uniform distribution of points. And let's add 2 zeros here before the 1, so we will have plenty of resolution. Awesome. Now, because we want to do this distortion, we also want to turn this into real geometry. And what that accomplished is gave us access to every single point from this geometry, and we can use that to do whatever we want with those points. So let's do a set position, and now it's time to build our displacement setup. So I'm gonna start with a noise texture, and let's see what happens if we just take this noise texture and plug it directly into the offset of this node. We get this result. So first of all, let's make sure that things stay pinned to their original location. I'm gonna do a vector map operation on this, and this being a 0 to 1 range, if we subtract half of that value, we put things back. So it's like not having this, we just have the distortion. Awesome. So now that we did this, I kind of want to push everything in the direction of the normals to get some different result than what we see here. So let's do a vector math. I'm gonna do a multiply and I'm gonna plug the normal here. So let's plug the normal here. Excellent. And once we did this, I want to duplicate this node to get us control over the intensity of this effect. So let's put a scale here. Let's say something like this. And now we have a control. And this one will make sure that we get as much distortion as we want. Excellent. Now that we created this, let me switch to 4D because I want to add some animation to this effect. And if we want animation, we will need this input scene time node that we want to use it to control this W value. If we play now the animation, we get this very, very fast effect. So let's control a little bit the speed by using a multiply node, and let's put a small value here. I think even smaller, something like this. No, even smaller, something like this. Yep, now it's looking much better. Let's look at this noise. We can add as many details as we want by playing with these values. This will look nice for now. Let's smooth the entire thing. I want to add a little bit of smoothness. One easy way to smooth things out, given that this is a curve, is to change the handle type. So auto looks fine, but we get an error message saying that we need a different type of curve. So let's use a set spline type here and switch this one to Bezier as instructed there. And as soon as we do this, we get that smoothness, as you can see here. Awesome. That is looking very, very nice. Now that we did this, I want to add some depth to this text. I want to make it three-dimensional to go, let's say, up or something like that. And in order to achieve this effect, we need to convert this to a mesh. So let's do curve to mesh, plug here, and let's see what profile do you want. We want, let's see, let's add this quadrilateral thing here and plug it into this socket. So now we get this ugly result because, well, everything is way too much. So let's say that I'm gonna put something like maybe this here, and let's do something similar to the other one. And we get this result. So let's make this more of a height thing. And as you get closer, you will see that we need to close this profile now, but I'm leaving it closed anyway. Great, now we have a three-dimensional shape here. One more thing that I want to do in preparation of the geometry node. If we look at here, we don't get any UV mapping. So I want to create one. And in order to do that, I'm gonna need to transfer some data from this curve. So let's say capture attribute, plug this one here. And let's see, I want to use the spline parameter with the factor input. That's gonna give us a gradient from 0 to 1 on this direction of the spline. And let's do Control Shift D to copy with the connection. I'm gonna cut the first connection and I don't want this node. I want this to be connected here. and this to be connected here. I honestly don't like the fact that they removed the noodles when you do the dragging. It's confusing for me, but hey, it is what it is. So now that we have this connected here, we get a gradient from 0 to 1 on the height as well. So what can we do with this? We can do a vector combine x, y, z. Take this output and plug it to x, take this output, plug it to z, and take this and plug it here. So now if we open the panel, we can play with this. Let's go to the group. This will be our, let's say, squiggle UV. I'm gonna copy this name because I want to use it here in this output. This is important, and this is going to be our UV map in the material. So while I had this panel open, I want to show you that I have some materials that we will assign to this geometry, different colors. These are just placeholders, so we have an idea what's going on. Okay, so now we have this UV. It's time to add some materials here. And adding materials, it's kind of easy. You have this nice node, set material. We can plug it here and choose something, let's say the blue material. And if we go to material preview, everything goes blue. Excellent. But as you saw in the demo, we had a material on the top here. And we also saw in the demo how the material from the top started to spread around here. Let me switch to the red material so we can see the squiggly lines. So we had a top material, and at some point that started to spread around the material. So how was that done? Well, we used a mask. So let's create a mask for that effect. Let's start by creating the mask for the tip. And in order to do that, we will use the position. So let's take the position, plug it somewhere here. And I want to separate the components. So let's write separate and choose X, Y, Z. Okay, great. And once we did this separation, we will need a compare node to get a Boolean value that we will use for this red material. So I want to isolate the top part from here. So as we look at the geometry, I want to isolate everything at a certain point here. So let's take the Z and plug it here. And let's say if everything is greater than a certain value, we must get this material. So let's see. If we look now, if it's greater than 0, as you can see, we have this material here, and that's great. This is what we wanted. That will be one mask to use. But I want another mask that will allow us to put this material here. But first, let's see how we can add another material on this. Let me take this node and switch it to the blue. And as you can see, now we have the two materials. It's important to put the one with the mask afterwards. So we first assign this material to the entire geometry, and then we assign this material only to the masked part. That's the idea behind this. So let's create the mask that will allow us to assign material on this direction. And for that, I'm going to use the index. It will be a very nice and cool trick, you'll see. So I'm going to take an utilities Boolean math node and plug it here and say the operation that I want is OR. So we basically have this output that will allow us to add to this mask that we will create now. Like I said, we will use the index. So let's take the index here. I'm gonna put a frame on it, so we have an idea on what module are we working right now. Okay, a quick save. And now if we take a compare node, let's plug it here, the output, and let's put this node here. If I take this index, plug it here, and say switch to less than, now we have a value that will control the index. So if I put something like this, as you can see, we start to get the effect that I wanted by playing with this value. But that's not exactly what I want, because this is kind of hard to control. I would like to have a 0 to 1 factor. So how can we build a 0 to 1 factor here? Well, okay, let's see. Where do we have the number of points? We turn everything into a mesh. And at this point, before we start to play with the materials, we get the number of points. This is what I want, this number of points. So in order to access procedurally that information, let's take a domain size. Mesh is fine because this is what we have here. And plug this one here. And now we have access to this value, the point count. So if we take, for example, a map range, and let's say I'm gonna plug the index here, and I'm gonna plug the result here. So we are basically passing this through the index, through the map range. I want to start at 0 because this is the index 0, and I want to end at the last index. That will be the point count. Let's do a control H. We don't need all the outputs. A point count, but -1. Because when we look at this, the point count is the total number of points, but the index starts at 0. This starts at 1. So this is an easy fix. We can plug a math node here, change it to subtract, and put this one to 1. And now we have a 0 to 1 factor basically here that is fed here. Because we reconverted this insane number of 188 and something points to this 0 to 1 factor. So now if we play with this, we get the entire effect. And that's a lot more predictable and easy to use. So we basically done this part. We created our first effect. And now it's time to create the pin letters. So in order to do that, let me duplicate this frame. I'm gonna output this here, and let's see what do we want to do with this. In order to create the pin effects, we kind of need to use a different geometry on this. So let me take this also out, and let's see. For starters, let's use this geometry as is, and that's gonna give us this result. We go back to square one, so to speak. And now that we did that, let's think about it. We want some geometry to be instance on these points. So let's start with instance on points and plug this one here. This will be our points. And we need something to instance on. And for that, I'm going to use a cylinder. So let me plug this cylinder here. and plug this one into the instance here, and we get this result. Because the radius of this is way too big, let's try something like this, and now this is too small, so let me cut 1 0 from here. Yep, maybe a little bit thicker, something like this, and we see a bunch of problems. First of all, we have this depth, we can control it, very nice, but as you can see, we have very little geometry. That means we kind of want to do the same thing as earlier. That means we want to resample this. So let's do a curve, resample curve, plug this one here, switch again to length because I kind of want to have an uniform distribution. But this time we are not going to need that much geometry as before. Let's see if we do like this. It's already plenty. So we can even go lower. The final value will be shown in at the end on the overviewing of the setup. I'm going to show you a few tricks to expose values and get some predictable parameters. Now we are just focusing on creating this effect. So we got this geometry. Let's add a set shade smooth for this. Okay, and as you can see, everything gets smoother but also mushier. And in order to fix that, let's go back to this cylinder and play a little bit with the values. First of all, I want to have 6 values here to get a hexagon. And then I want some geometry on the side segments. That's going to help with the mushiness. And also fill segments. And we get something like this. You can increase the values more, but for the sake of responsiveness, I'm going to leave it like this. And once we did this, we can take care of setting up the materials. So let's plug a material, set material here. And once we did this, let's put the blue material here and then duplicate this. Actually, can move this one, something like this. Let's put the red material here. And of course, we kind of have to build a mask again. And for this mask, I want to use the same index tricks as we did here. So let me take these nodes from here and do Shift D, Alt P to remove the frame, Control J to make a new frame, and G to plug it here. So now we have this mask here that needs a domain size, and the domain size is going to be our geometry here. So let's plug it here. Awesome. And now we can plug this one here. And again, we have a 0 to 1 factor that we can easily expose in the modifier stack, and this value will control the spreading. So let's do something like this. You can pick this value to get some other result. I'm going to leave it like this. So now we have a mask for the tip, and that's what we try to do. So now that we have this mask and we created the second effect, it's time to think about the next point, and that will be mixing those effects. How can we mix these two effects that we have here? Well, the name says it all. We will need a mix node. So let me take this mix RGB. For now, this is what we have. We will end up with more mixing options for vector and stuff. So let's see. This will be the mixing part. But before we do the mixing, we kind of have to separate these effects, because now we can use either of them, but not both. So let me do a join geometry and plug those here. And now we have both overlap. That means that we kind of have to build a mask. So let's do a mask here. I'm gonna plug the mask here, and the mask will consist in separating the geometry. And that's actually a very cool trick that I found out accidentally by playing with values. And that is how you can separate the inside of a letter, like we have for O, or for P, if we add, let's say, a P here. Let me switch it to the top view. How you can separate this inner part from the outer part. And that's what I want to show you now, how to create that. And it's incredibly simple. Let me take a random value. I'm going to switch this one to Boolean operation and plug this one here. And of course, I want to switch this one from point to spline. And voila, as you can see, we have now this separated. I couldn't believe when I stumbled onto this. It's that simple to separate the inner parts from the outer part. Put this one to spline and use a random value to separate. Control Z. I didn't want to group this. I wanted to create a frame for this. So now that we separated this, let's see. We have this one that goes here and this one that goes here. Great. And now we have the two effects here. Control X to remove these dots here. And let me plug this one into this frame. Great. Now we have a separation. So now we can use the mix node to play with the transforms, switching from this position to this position. This is what we want to do, basically. To take these points and put it here. So how can we do that? Because right now we have this effect and this is static. Well, if we want to use in this branch here the position, that means we need this node, set position. So let me plug it here. Great. And the way to mix it is to get the position from this setup here. So what is the position that we care about? Well, we have this output here, or we ended up creating the geometry, and we passed the result to a mesh, and we smooth the mesh. So this is the result that we want, that is gonna follow the curve exactly. And the way to extract that information is this is interesting, and you will see why it's interesting in a moment. So let's take the position from here. Like I said, the way to extract this is to do a transfer attribute. So let's take the attribute from here. And what attribute do we care about? The position. So that means let's switch this one to a vector and plug this into the attribute. And now let's say switch this one to nearest, and point is just fine. And let's see what happens if we take this position and we plug it here into this node. And as a second position, we want here to have input position, the position of this geometry that we have here, meaning the output one, the outside one. And let's plug this one here. We get this result, which is, let me put this one to 0 and to 1. 0 is this position, and is definitely not what we want. And if we go back here, we get this message. The target geometry must contain a mesh or a point cloud. So what we have here, it's not good. It's not what we need. So let's see. We could use this one from here, but it's still not good enough. It's not giving us what we want. So how can we fix this? And that's the interesting part. Let's turn this curve into points. So let me take a curve and curve to points and plug this one here. And we get this result because we have another problem. This count number that should be corresponding with the number of points that we have. So let's see. If I go to, again, domain size and take this input from here and switch this one to curve, we get a point count, and that's what we want, to get this point count here. Awesome. So even though you did all of this, we still don't get the result that we want. And the answer is simple, because here, if we look at what we are doing here, we are still working with instances, but we want to move the individual pins. So that means that we have to turn these instances into real geometry. And as soon as we do this, we get what we wanted. We get this effect coming here. Excellent. So now we get the position of these points modified here. We get exactly the same number as this one has when we turn it to points, and we mix this effect. And I would like two things to happen. When these dots are here, I would like them to not be seen, to have a 0 scale. That will be the easiest way to do it. And I also want this not to go like this. I want to have some randomness involved. So let's do that now. First of all, let's fix the scale problem. And for that, I'm going to take in instances, scale instances, and plug it here. So we have the instances coming from here. We did all the stuff here. We have the instances coming out, meaning this geometry. And now we want to play with the scale. So let's do just temporarily take a value, plug it into the scale here, and plug it into the factor here. And you see all the points are disappearing because they have a 0 scale. But if we play with this value, we will see them coming up and down. And that's what we want. But we want to change this static value to some cool randomness. And in order to do that, we kind of have to keep a 0 to 1 factor here. But we also want to add a random value. So let's see, we take a random value here, and we have a 0 to 1 range. And we want to add this value to this value. So let's do a math, plug these ones here, take this value with this value. So now we have this controller here that is doing the random thing when we are, let's say, start at -1, and we start to increase. The points are doing like this. So we get our randomness. But as you can see, if we are at 0 some of the points are already working. If we are -1, meaning even the maximum value of 1 added to this will give us 0, we get this result because we get an inverted scale. So how can we keep everything still in the 0 to 1 range? We have a very useful node for that. It's called clamp. So let's plug this one here and put this into a 0 to 1 range. So now if we play with this value, we get exactly what we want, and everything stops where it's supposed to stop. And that's giving us the result that we wanted. And of course, now if we want, we can play with this and put whatever text we want here. Let's say forever I used. And as you can see, the inner parts are the one that get the squiggle effect, and the outer parts are the one that get the pin effect. And that's basically what we wanted to do. What I want to show you is the finished setup. And that's interesting because I will also show you how I exposed some other values to create more predictable parameters. So this is the point that we will touch now. So that would be the end result of this project. Like I said, the materials and lighting will be dealt with the lights, sorry, will be dealt in the complementary video. I'm going to show you the cleanup node tree and show you how I created these parameters here that allows a lot of control, because this is how I animated the effect. I have a 0 to 1 slider that controls the entire effect. I expose the text parameter, the height that controls both the squiggly effect and the pins, and I can control the squiggle intensity, how fast this line moves, the resolution of this line, if I have or I don't have this glow tip. I have this value exposed that also controls this movement that we saw in the demo, and I also can control just how dense the pin array number is, or how much of their surface is glowing by playing with this value. I can increase the glow, as you can see. So pretty cool results, I think. So let's look at the node tree. We started by having this text control, and I exposed the string. We created these cool masks to separate the inner parts to the outer parts of the letters. And for the inner parts, we resample it and created this displacement after realizing the instances, because we have instances for each letter and we want geometry to displace. And the way I exposed that to turn into a 0 to 1 range was plugging this map range, so you can control the resolution of the spline. The displacement is here. We use the noise texture. We animate it using the W value. This is the final values for the noise texture. These nodes make sure that the letters stay in place, they don't fly off. And I pushed everything along the normals, and I exposed this node is controlling the intensity of the animation of the squiggle lines, and I exposed that parameter. And in order to create a more controllable animation, I took this 0 to 1 range of this node that it's giving us, as you can see, the squiggle speed here. And I created this custom float curve that is making sure that we stay on some low values, as you can see on these nodes, all the way to 85% of that range, and then we ramp up to a very high speed of 1. So that gives us a better control, because this is a very, very sensitive value. So you basically need a very small value to make it go slow, as you can see here, 0.001 or something. So this is how I created that output. After displacement of the squiggle, we did a smoothing of this by changing to the spline to Bezier and setting the handles to auto. And we also got the position from these points and resampled this curve, then turned it into points, taking the number of control points from this spline and plug it here. That was for the mixing. But back to the squiggle, we created the UV map here and we gave it a profile, basically a square or a rectangle actually, that is giving us this profile that we see here. So after that, we created two masks, one for the tip of the light of the squiggle and one that is giving us this result here that we see here. This one. This is controlled by this mask here that I showed you earlier. And then we did the material, first the one for the entire geometry, then the one that is masked. And this is the output. Join geometry, set everything smooth. And then I made sure that you can basically change the height of this squiggling. So you can, let's say, put the height higher. And let me put the geometry on solid. So you put the height higher, but it grows from the bottom, from here, instead of growing it from here in both directions. And the way I did that was with this setup. I did a set position. I took the height, divided by 2, and offset it in the z-axis by half of that value. So if we have 0.1 displacement here, we basically push everything up half of this value. So we end up making things grow from the bottom. For the other part of the setup, we did this after separation, realize the instances so we can play with the points that are coming from here and resample the curve. Again, I use the map range, but with different values to resample this. And we instanced it on these points. We instanced this cylinder. This depth is using the height that it's actually used by this setup here, the squiggles, so they are in sync, they have the same height. I added a little bit of resolution to get smooth result to these pins, if we go close to look at them, to get this result from here. And then I selected the tip of this material by using the same style. Index, got the domain size, -1 to get a range from the 0 to the last point. That gives us a factor from 0 to 1 that you can control the pin glow, as you can see from here. We can play with this pin glow, as you can see here. And of course, adding the basic material and then the one with the mask on it. After that, we did the actual mixing. We got the position from the squiggles and we transfer it to the pins using a mix node, and we add randomness by playing with the random values. Again, a 0 to 1 factor. I remap it from -1 to 1 to do this thing that I showed you earlier. And that's kind of what I did also, plugging the instant scale to this output. So when the pins are on the squiggle or close to them, where on top they are 0, and then they start to grow as they move further away from the squiggle to their final position. So that's it. That's it for this tutorial. It was a really fun project to make, and I'm glad that I could show you a few techniques that you can use in your projects to make very cool stuff. So having that in mind, happy blending and have a nice day. And of course, thank you again for watching this video and supporting this channel.